Today in the workshop, we'll be taking our first look at the Seeeduino XIAO. We'll examine the features and capabilities of this tiny but powerful 32-bit microcontroller. We'll also see how we can use Arduino code and libraries with the XIAO. Good things come in small packages, so welcome to the workshop. Well, hello and welcome to the workshop, or I should say welcome back to the workshop. It's been a little while since I created a video, and I apologize for that, but I have been very busy doing some renovations down here in the workshop, including adding a new area to the workshop that I'll be showing you in a little while. Let me just say that if you think I have a lot of parts drawers over here, you ain't seen nothing yet. At any rate, I have something else new in the workshop, and that's what I want to talk to you about today. And it is a new microcontroller. It is called a XIAO, and it is made by Seeed Studios. It's part of their Seeeduino line. This is an Arduino-compatible microcontroller that uses the SAMD21 chip that a lot of other microcontrollers use, and that makes it much faster than the Arduino and more capable. It has more I/O devices and more interrupts, and it is also very, very inexpensive and very, very tiny. It's an excellent device for wearable projects, and it's also an excellent device just for general purpose projects. Now, XIAO is a rather odd name, and I didn't even know how to pronounce it at first, to be honest. It's spelled XIAO, and so I did a little bit of research on it, and I found out that a XIAO is actually a musical instrument. It is a flute that was created in China about 28 centuries ago and is still around today. Now, I'm not sure why they decided to name a microcontroller after a flute. Maybe they were hoping for the same product lifespan, although 28 centuries is a pretty long lifespan. But at any rate, it is a quality-built product. As I said, it is very inexpensive. It's less than $5 US for one of these boards, and it has a lot of advantages over an Arduino. So what we're going to do today is we're going to take a detailed look at the XIAO, see how it works, and see how we can program it. So let's go and start with that. The Seeeduino XIAO was designed by Seeed Studio and is part of their Seeeduino line of Arduino-compatible microcontrollers. The device uses one of the SAMD21 microcontrollers, a 32-bit controller that is running at 48 MHz. It has 256 kilobytes of flash memory and 32 kilobytes of static RAM. The XIAO has a USB-C interface which also provides power to the device. Its extreme small size and low current makes the device ideal for wearable and portable projects. Another advantage of the XIAO is it's very inexpensive. These devices are less than $5 US a piece. The XIAO has 11 digital I/O ports. It has 11 analog inputs that use a 12-bit analog to digital converter. There is also one digital to analog converter that provides an analog output. All of the pins on the XIAO support interrupts. 10 of the pins are pulse width modulation capable. The device has an I2C, an SPI, and a UART interface. It also has 6 SIRCOM serial interfaces, which can be configured as additional I2C, SPI, or UARTs. Let's take a look at the pinouts on the XIAO. Unlike many chips, this one starts labeling the pins at pin 0, so the 14 pins go from 0 to 13. 3 of the pins are being used for power. Pin 13 is being used for 5 volts, pin 12 for ground, and pin 11 for 3.3 volts. These pins provide outputs from the XIAO's internal voltage regulator when using the USB-C connector. There are 11 analog inputs, A0 to A10. These are all 12-bit analog inputs. The same pins are used for 11 digital I/O pins. Remember that the XIAO is a 3.3 volt logic device and is not 5 volt tolerant. Many of the pins have other functions as well. Pin 0 is the output of the digital to analog converter, so this is the analog output. Pin 1 is the reference pin, the equivalent of the AREF pin on the Arduino Uno. This can provide a reference voltage for the analog to digital converter. Pins 4 and 5 are the SDA and SCL connections for the I2C connection. Note that these mimic the same connections used on the Arduino Uno. Pins 6 and 7 are the transmit and receive, respectively, for the UART. And pins 8, 9, and 10 are used for the SPI connection to the device. All of the pins on the XIAO support interrupts. Some of the interrupt pins are rather unique. The pin 4 interrupt is a non-maskable interrupt. Other interrupts can be masked and ignored, but this one cannot. Also note that pin 5 and pin 7 are both tied to interrupt number 9, so they can't be used simultaneously for interrupt purposes. With the exception of pin 0, all of the pins on the XIAO support a PWM output. On the top of the device, the most prominent feature is the USB-C connector. This is used for both power and data. Reset on the XIAO is performed by connecting 2 of the pins on the top together. There is also a procedure for doing this multiple times to reload the bootloader. The XIAO has 4 LEDs. The one labeled L is the user LED, and this is the equivalent of the pin 13 LED on an Arduino Uno. The T LED is the UART transmit indicator. The R LED is the UART receive indicator. And the P LED is the power indicator. On the bottom of the XIAO, we see some additional connections. There are 2 connections for a serial debug. There's also a repeat of the reset with the associated ground connection, and another power connection with a ground and a V-in. This is very suitable for wearable applications. The SAMD21 processor used in the XIAO is also used in several other popular microcontrollers. You can program the Seeeduino XIAO using CircuitPython, which is a subset of Python created by Adafruit for microcontrollers. You can also use the Arduino IDE, which is what we will be using today in our experiments. Now let's do a quick comparison of the XIAO and the Arduino Uno. The XIAO uses a 32-bit SAMD21 microcontroller, whereas the Uno uses an 8-bit ATmega328P microcontroller. The XIAO is clocked at 48 MHz, which is 3 times faster than the 16 MHz clock used on the Arduino Uno. The XIAO has 256 kilobytes of flash memory, as opposed to the 32 kilobytes of flash memory on the Uno. The XIAO has 11 digital I/O ports. The Arduino Uno has 14 digital I/O ports, and keep in mind you can also use the analog ports on an Uno to give a total of 20 digital I/O ports. The XIAO has 10 pulse width modulation capable ports. The Arduino Uno only has 6. The XIAO also has 11 analog inputs, and these use a 12-bit A to D converter. The Arduino Uno has 6 analog inputs, and it uses a 10-bit A to D converter. The Seeeduino XIAO has 1 analog output, whereas the Arduino Uno does not have any analog outputs. The Seeeduino XIAO can be purchased individually or in a handy 3-pack. So now let's take a look at this amazing little microcontroller. Now here I have a 3-pack of the Seeeduino XIAO, and I want to show you the difference between it and a number of other common processors which I have over here, specifically the size of it. So let's take a look at the XIAO first. Let's move this box aside over here. This is the XIAO. As you can see, it's extraordinarily tiny. And here's a couple of other processors you can compare it against. This is the Arduino Uno, of course, and as you can see, this thing is just a fraction of the size of the Uno. It's barely bigger than the USB connector on the Uno. Here's an ESP32 and ESP32 cam, and again, as you can see, the XIAO is much smaller than those. This is an Arduino Nano 33 IoT. It's the same size as the old Arduino Nano, but this unit actually uses the same microcontroller that the XIAO uses. But again, you can see that you could probably put 3 XIAOs in the space of that. This is an Arduino Pro Mini, which is maybe about twice the size of the XIAO. And this is the only thing I could find that really compared in size to it. And this is a small ATtiny board. Now, of course, if you want to compare the capabilities of an ATtiny board with only a few I/O ports to the Seeeduino XIAO, there really is no comparison in performance, number of ports, etc. But they are roughly the same size, although the XIAO is even a little tinier than that. And this is a Raspberry Pi Zero, which of course is not a microcontroller, it's a microcomputer. But I brought it out here because this is approximately the same price as the XIAO, and of course this is a complete little computer. It has an HDMI output, etc., etc. But as you can see, it is much larger than the Seeeduino XIAO. Now, you saw already in the animated presenter what the pinouts and everything of the XIAO are. As you'll notice, it comes without the pins soldered in. They give you the pins. They also give you in the box a number of these little stickers that you can stick onto here to help you with the pinouts. And of course, you don't have to solder the pins on. You could surface mount this thing if you wanted to. You could solder the pins on the other way, use female pins, or only solder to the connectors that you actually need. So it's a very versatile little device. The Seeeduino XIAO is a relatively new microcontroller, and as a result, there's not as much information out there about it as there is with established controllers like the Arduino Uno or the ESP32. However, there are some good resources online that you should be aware of. One of the main resources, of course, is the wiki that Seeeduino has provided for the Seeeduino XIAO, and this actually gives you quite a bit of information about the XIAO and about setting it up and demonstrating with it. Another resource Seeeduino has provided is a resource page, and on this resource page, which they continually update, they will add links to other articles and resources for the Seeeduino XIAO. Another place you can go is the Seeeduino forum. They have a specific forum for the Seeeduino XIAO within their forum, and you can communicate with other XIAO users there, ask questions, and actually take a look at some of the other questions which may answer some of the queries that you have. And finally, another resource that I found that is very good is this blog over here, and you can find the URL to the blog inside the article that accompanies this video on the DroneBot Workshop website. I use this particular blog for a lot of the information that I had for the XIAO. This is made by a user who got an early copy of one of these and basically dissected it. He has a number of other articles on here as well on the XIAO, including articles on using the XIAO with Platform IO, which is a different IDE than the Arduino IDE and is superior in many ways. And you'll be seeing Platform IO, by the way, here in the DroneBot Workshop as well. And so you'll find the link to all of these resources on the article accompanying this video on the DroneBotWorkshop.com website. So now that we've seen the XIAO, let's start and work with it. Now, I mentioned that the XIAO could be programmed using either the Arduino IDE or using CircuitPython. Well, today we are just going to focus on the Arduino IDE. The XIAO is a little bit like the ESP32 in that you have to set up a new boards manager in your Arduino IDE in order to work with it. So I'm going to show you how to do that right now, and then we'll run some very basic tests on the Seeeduino XIAO. In order to work with the Seeeduino XIAO and the Arduino IDE, you're going to need to install an additional board manager. If you've used the ESP32 with the Arduino IDE, you've done this already, and it's a similar procedure. You need to go into File, and then go into Preferences. In Preferences, you'll see a box for additional board manager URLs. Now, if like in my case, you've used the ESP32 or an additional board, you've already got an entry over here, but you need to put a second one in. So click this little button right beside the text box, and this will open up another text box. I'll just expand it so we can see it. And in the line below this, insert the URL for the board manager for the XIAO. Now, you can get this URL off of the Seeeduino wiki, or you can get it off the accompanying article to this video on the DroneBotWorkshop.com website. Once you've done that, click OK, and then click OK over here. Now that you've done that, you need to add the board to your Arduino IDE. Go into Tools, and then go into the board, and go into Board Manager. Up in the top, we're going to try to filter our search by typing in Seeeduino XIAO. And we get one entry over here, which we can install. Once the installation is complete, you can close your board's manager. And now when you look in your boards, you'll have an additional entry down over here for Seeeduino boards, including the Seeeduino XIAO over here. And this installs the Seeeduino board manager and boards into your Arduino IDE. Now here I have a Seeeduino XIAO, and it is hooked up to my USB port, and this is basically brand new out of the box. I haven't done anything to it yet, and you can see a flashing light on it, and that is because the XIAO, like many Arduino-compatible devices, already comes preloaded with the blink sketch. Now I want to show you something about my hookup, because we need to talk a little bit about USB-C cables. Not all of them are necessarily the same. The XIAO, of course, uses a USB-C connector for both power and data, but many USB-C cables are only made for power and do not carry data signals. And so it's important to use a USB-C cable that also carries data. Now what I've done over here, actually, I'll just take this apart for a second and show you, is I have used a micro USB cable and a micro USB to USB-C adapter. And I found that worked very well because the USB-C cables I happen to have in stock only seem to carry power connections, so you might want to keep that in mind. Bear in mind that if you connect the USB-C cable that only has power on it, you will see the blinking light, of course, because the sketch is already loaded, but you'll run into problems when you go to upload sketches. Now if we go over to the blink sketch, we can upload another version of it. We'll just change the rate of the blink. Let's change that down to 3000. And so that should give us a 3-second blink instead of a 1-second one. Now up in the tools over here, we have to make certain, of course, we have the right port and board. So under the board in the boards manager, you're going to go into this new section that you just installed, and you're going to pick the Seeeduino XIAO. And then over here on the ports, look for the port that says Seeeduino XIAO on it, which in this case is this one over here for me. Now this is a good way to determine if your cable actually has data connections, because if it doesn't, it won't say Seeeduino XIAO on the port, but the port will show as being available. So that's a good clue as to whether or not you really have the right kind of USB-C cable. And so I'm going to upload that to the XIAO, and you don't need to do anything like you do with the ESP32 by pressing any buttons or anything. You just upload it as you normally would for an Arduino. And let's take a look at our XIAO over here. And now, as you can see, the blink rate has changed. So we have indeed successfully uploaded to the Seeeduino XIAO. So now that we've hooked the XIAO up to our computer and have successfully used the Arduino IDE to send it the blink program, we can move on to examining some of the other features of this microcontroller. What I'm going to do right now is hook up a very basic circuit. Now it really doesn't do very much. This is just a demonstration circuit, and it'll show you how to use some of the different I/O capabilities on the XIAO. For the test we're about to run, we will of course need a Seeeduino XIAO. We'll also be using a potentiometer. Now I used a 10K pot, but any value from 5K to 100K would work just fine. You'll need an LED, and I used a red LED, but the color shouldn't be critical. You'll also need a push button switch, and again, any type of push button switch will work as long as it is normally open. We'll begin by connecting the ground of the Seeeduino XIAO to one side of the potentiometer. We'll connect the 3.3 volt output of the XIAO to the other side of the pot. The wiper of our pot will be connected to pin 2 on the Seeeduino XIAO. We'll connect the anode of our LED to pin 9 of the XIAO. We'll connect the cathode of that LED to ground. Note that we are not using a dropping resistor in this circuit. We'll connect one side of the push-button switch to pin 7 of the XIAO. The other side of the push-button switch will be connected to ground. Again, note that we are not using a pull-up resistor. Finally, pin 0 of the Seeeduino XIAO will be connected to pin 4. And this completes the wiring for our test experiments. So our first test sketch is going to be a test of the analog input pins. And what I want to illustrate with this is just a few differences between running a sketch like this on the Arduino as opposed to running it here on the Seeeduino XIAO. Now this is an extraordinarily simple sketch. We start off by defining the analog input pin that we're using, and that's A2. Of course, you could use another one of the analog input pins. There are 11 of them, and you would simply have to change the value over here. I've also defined an integer that represents the input value that we're going to get back from that analog pin, and I called it input_val. Now the setup is where I want you to notice a couple of differences between this sketch and one that has been written for the Arduino. The first thing we do is we set the analog read resolution, and I'm setting it to 12, which is 12 bits, and that's the maximum resolution of the A to D converter. Now you can set this for a different resolution if you want, 11 bits or 10 bits, if you don't want as high resolution out of your A to D converter. If you eliminate this statement, however, the analog to digital converter will default to 10 bits, not 12 bits. And this is for backwards compatibility with old Arduino sketches, because you normally don't add an analog read resolution statement in an Arduino sketch, and the Arduino has a 10-bit A to D converter. So if you want to get the full resolution of your A to D converter, you need to put this statement into your setup. The second thing I want you to note is how we are using the serial port. You will notice that instead of serial begin, I've got serial USB begin over here. Now this is unique to the SAMD21 processors, and other boards that use this processor also use this same comment. Serial USB is one of the serial commands supported by the Arduino, and serial USB uses a direct connection to the high-speed USB port that is built into the SAMD21 chips. The ATmega328 chips do not have a built-in USB port. They use a separate chip in order to drive USB, but this is built into the SAMD21s. Now another thing about this statement is I've got a speed over here of 9600 bits per second. That's actually a farce, and I could put any value I want into there, because the serial USB port does not require you to specify a speed. However, if you don't put a value in there, the Arduino IDE will fail to compile over here. So you need to put something in here. But just keep in mind that this does not have to correlate to the speed that you're running your serial port at, because serial USB does not really require that. After that, the loop is pretty well exactly what you would expect. We do an analog read, as we would with an Arduino, of the analog in pin, and assign that to the input val, and then we will print that to the serial monitor. Again, notice the use of serial USB over here. I've added the slight delay over here, and then we just go and repeat the loop again. So an extraordinarily simple sketch with a couple of different statements up here that you need to take note of when you're working with analog devices on analog inputs on the SAMD21 processors like the Seeeduino XIAO. So now let's take a quick look at it in action. And so as you can see from the serial monitor, we're getting a value back from our sketch, and as I twist the potentiometer, I can send it down towards 0, although interestingly enough, mine won't go all the way down to 0. Now this is a very sensitive A to D converter with a maximum voltage of 3.3 volts, so I suspect I might be picking a little bit of noise up on this. However, I'll increase it in the other direction, and as you can see, we go all the way up to 4095 on the other end. So we do indeed have 12 bits of resolution as opposed to the 10 bits of resolution that you would be used to with an Arduino Uno or another AVR type of Arduino. And so this is a very simple demonstration of the analog to digital converter on the Seeeduino XIAO. Now in our next sketch, we're going to check the operation of the digital I/O ports on the XIAO, as well as the operation of the built-in LED. And once again, this is a very, very simple sketch. We start off by defining the inputs for the push button and the output for the LED. And you can, of course, connect these to different pins if you wish and just alter the code accordingly. We also define a Boolean that I'm calling button state, and this is just going to represent the state of this push button, whether it is a high or whether it's a low. Now in the setup, we do a number of pin mode commands. You'll recall that we did not use an external pull-up resistor for our push button. Instead, we're going to use the internal one in the XIAO. So we do that by doing a pin mode and using input pull-up as our parameter. Now the LED is set to an output, and it's done in the normal fashion, pin mode LED output. And we're going to do the same with the built-in LED on the XIAO as well. And the reason for doing this will become apparent when we run the demonstration. We're also setting up the serial port, and once again we use serial USB, and we pass it a baud rate that is completely irrelevant because it's really ignoring it, but the compiler will require it. Then we're going to go into the loop, and the loop is very simple, and I know a lot of you are going to say you could have probably done it all in just about one statement, but I broke it down into individual statements for a reason. First, we're going to assign button state to the value of the digital read of the button, and that's pretty straightforward. And then we're going to print that button state out to the serial monitor, also pretty straightforward. Then we're going to simply write to the LEDs with that button state. So we're going to write to the LED and the built-in LED. And again, the reason for doing this is going to become apparent in our demo. So let's go and take a look at that demo, and you'll see why we're driving 2 LEDs instead of 1. Now, believe it or not, this demonstration is probably the most difficult thing I have ever had to film for a DroneBot Workshop video, and I'll tell you why. As you can see, I've got a very close-up view of the Seeeduino XIAO right now, and you can see my LED over here, which is currently on, and here's my push button. And the fact that the LED is currently on will make some sense, especially if you look at the serial monitor and realize that right now the push button is at a state of 1, which again makes sense because the button goes to ground and sends things to 0. So the button is at a state of 1, and the LED is on, and that makes sense. But what is difficult to film is down in the corner over here we have a very tiny LED, and that is the built-in LED. And what I want to demonstrate is that as I push the button, our main LED goes off, but this other one actually comes on. Now it's very difficult to see. It's over here in the corner. I'm hoping you can see the little yellow thing. I've tried all sorts of angles on the camera, and I'm afraid this is about the best I can get. But what I wanted to illustrate is that the built-in LED operates in the opposite fashion to the built-in LEDs on the Arduino boards. On the Arduino board, the LED is activated at a logic 1 or a high. On the Seeeduino XIAO, this LED is on when the logic is low, so it is exactly opposite. And the same is true, by the way, for the other LEDs on the board over here, the 2 blue LEDs that reflect the transmit and receive respectively, which are also connected to D12 and D11. They also work in the same fashion. They are on when the signal is low and off when the signal is high. So that's one important difference between the Seeeduino XIAO and the Arduino boards. Now in this sketch, we're going to do a demonstration of the analog output capabilities of the Seeeduino XIAO. And of course, the Arduino AVR boards do not have an analog out. So this is not a comparison to an Arduino, but just something to show you how to use analog out. Now this is based upon a sketch that Seed Studio had provided on their wiki. And essentially all I've done to the sketch is I've cleaned it up a little bit. They had, for example, a variable in that sketch to represent frequency. They defined it but never used it, so I just removed it. And I also just cleaned up the code so it's a bit more readable, but otherwise it's essentially the same sketch. Now we start by defining the analog output pin that we're going to use, and in this case we cannot change this. A0 is is the only pin connected to the digital to analog converter. We have to use that as our output pin. We also define an analog input pin, and of course if you want to move it from A4, you can move it to any of the other inputs. We're defining a float as well, a couple of floats that we are going to modify to create our simulated sine wave. One called outval, and we're going to initialize at 0, and another one called increment. And the increment is the amount that we are going to increase the value of outval and therefore simulate a sine wave. Now in the setup we see a command we haven't seen before, analog write resolution, and below it we have a command we have seen before, analog read resolution. Well, I'm sure you can probably guess what analog write resolution does. It sets the resolution of the digital to analog converter, and the maximum resolution on the Seeeduino XIAO is 10 bits, and that's what we've set this to. We also set up our serial port, again using serial USB and passing it a baud rate that's completely irrelevant. Then we go into the loop, and the loop is where we're going to generate our sine wave. Now, remember our analog output is a 10-bit, so it can represent any value from 0 to 1023. Now, as we can't go below 0 and do a negative voltage, we're going to offset our sine wave to the halfway point, and halfway to 1023 is 511.5, which is why we're using this number over here. And so basically we take the halfway point and we add to it the sine of outval. Now it's going to start off as 0, and basically we're going to change that value. So we're going to do that and continually increment that in order to make a sine wave. We're going to output this to the digital to analog port, and you'll notice we use an analog write command, the same command that you're used to using for pulse width modulation. When you use the analog write command on a digital to analog converter port, it outputs an analog voltage as opposed to a different PWM pulse width. And this is actually the true use of analog write if you think about it. Then we're going to read that input from the pin that we've connected our analog to digital converter to. And we're going to take that reading and we're going to do some math on it. We're going to multiply it by 3.3 over 4096. 3.3 being the maximum voltage that it can get, and 4096 being because we're using a 12-bit converter and we have 4096 different potential values coming out. Notice that because it's a float, we also use the decimal point over here. Then we're going to print that to the serial plotter using the serial USB print. Of course, you could use the serial monitor, but you just get a bunch of random numbers which wouldn't mean anything. The plotter gives you a visual representation which should look approximately like a crude sine wave. Then we're going to add a small delay, and if you want to change the frequency of the sine wave, you can increase this delay or set it to a different value accordingly. But it's a relatively simple sketch, a few commands we haven't seen before if we haven't worked with a digital to analog converter, but let's go take a look at it now in action. Now, if you haven't used a serial plotter before, it's basically the same as using the serial monitor. You go under Tools, and you will find Serial Plotter. And we'll bring that up, and as you can see, we have a very approximate, crude emulation of a sine wave over here. So this is the sine wave that we're outputting from the digital to analog converter into our analog to digital converter and reading it back and placing it onto the serial plotter. So it's a fairly simple demonstration and certainly not a perfect sine wave, but it does illustrate how you can use the digital to analog converter to produce an analog output voltage. For our experiment using libraries, we are going to be needing a Seeeduino XIAO and an AM2320 I2C temperature and humidity sensor. We'll also require 2 pull-up resistors. Now the value is not critical, and they can be any value from 2.2 to 10K. We'll begin by wiring 3.3 volts from the Seeeduino XIAO to pin 1 of the AM2320. We'll wire the ground connection from the XIAO to pin 3 of the AM2320. The SDA connection, which is pin 2 on the AM2320, is going to be wired to pin number 4 on the Seeeduino XIAO. The SCL connection, which is pin 4 on the AM2320, is wired to pin 5 on the XIAO. The two resistors will act as pull-ups. One side of each resistor will go to either the SDA or SCL line, and the other side to 3.3 volts. And this completes the wiring of our libraries experiment. Now, in order to use the AM2320 temperature and humidity sensor, we are going to need a couple of libraries, and we're going to use the library manager to install those. So go into Sketch and go into Include Library and go to Manage Libraries. This will open the library manager. Now go into the filter and type in AM2320. Now the top listing for the AM2320 is the Adafruit AM2320 sensor library. And this is the library that we are going to need to install. As you can see, I already have mine installed. If you don't have it installed, there will be a button on this side that you can click to install it. Now this library is dependent upon another library called the Adafruit Universal Sensor Library. You may already have the Universal Sensor Library installed if you've done some of the previous experiments I've presented here in the DroneBot workshop. But if you haven't, you will get a dialog box popping up during the installation of the AM2320 library that will ask you if you want to install the Universal Sensor Library as well. Choose yes to do that and install both libraries. After you've finished with that, you can close the library manager. Now the sketch that we are going to use is one that is included with the library as an example sketch. In fact, it's the only sketch included with this particular library. And we can get to it by going to the File menu, then going to Examples, and then scrolling down to Examples from Custom Libraries, and look for the AM2320 sensor library. Chances are it will be one of the first ones as the listing is alphabetical. The only sketch we can try is basic AM2320, and that's exactly the sketch we're going to use. So open that sketch. And here is the basic AM2320 sketch. Now, as you can see at the top of the sketch, we are including two libraries, the Adafruit Sensor Library, and that's the Universal Sensor Library, as well as the library for the AM2320. The sketch is very simple. We start off by defining an object that represents our temperature and humidity sensor, and then we go into the setup. Now, one thing you'll notice is that as this was written for the Arduino, we are using the command serial and not serial USB, and that is fine. That will also work with the Seeeduino XIAO. Now remember, in this particular case, we are passing the speed of the serial port in the begin statement, and this is something you need to note because you will need to set your serial monitor up to the same speed rate so that the display is actually correct. Otherwise, you're going to get a bunch of garbled characters. The other thing we do in the setup is we print to that serial port, and then we initialize the temperature and humidity sensor. And the rest of the sketch is extremely simple. We just do two statements to print to the serial port, and we print the temperature and the humidity by calling those functions from the AM2320 library. So we do a read temperature and a read humidity. There's a delay of 2 seconds applied at the end, and that is something you need to do because this temperature sensor needs to stabilize for about 2 seconds. So every 2 seconds you will print out a reading of the temperature and the humidity. So it's a very simple sketch, and the real purpose of this is to illustrate that we can use Arduino libraries with the Seeeduino XIAO. So let's run this and see what the temperature and humidity in the workshop is right now. Now here's my XIAO with my temperature sensor and the pull-up resistors on a solderless breadboard, and as you can see from the serial monitor, it is indeed measuring the temperature, which currently is 24.4 degrees Celsius and a humidity of 50.9%. And that pretty well correlates with the temperature and humidity reading on the clock that I have here in my workshop. The temperature is a bit higher than what the clock is reading, but this device is much closer to the heater in the room than the clock is, so it's probably pretty accurate. And so it's really a very simple circuit, and again, the main purpose of using it is to show you how the Seeeduino XIAO can be used with Arduino libraries without any modifications. So you can take a lot of your Arduino code and use it on this amazing little microcontroller. And so that wraps up our look at the Seeeduino XIAO for today, but it's certainly not the last time that you're going to be seeing the XIAO here in the DroneBot workshop. For one thing, I purchased a few of those 3-packs, so I've got quite a few of these little devices to play with, and I can see them becoming very useful for a lot of the projects that I'm working on over here. So you're definitely going to see more of this little microcontroller. Now, if you'd like some more information about the XIAO, or if perhaps you'd like to get the sketches that I used today in our demos, you can just visit the article on the dronebotworkshop.com website, and you will find a link to that article directly below this video. While you're on the website, please consider signing up for my newsletter. I send out an occasional newsletter just to let you know what's going on in the workshop, and I'm not trying to sell you anything or trying to spam you in any way. So you can sign up for that on the website. And you can also sign up for the DroneBot Workshop forums. If you're not a member of the forum yet, well, you're missing out, because it's a great place to go to get advice about all your electronic projects from other enthusiasts just like yourself. Of course, if you haven't subscribed to the YouTube channel, please do that. Please just hit the subscribe button at the bottom of the video and you'll be on the way. And make sure that you hit that little bell notification as well and have your notifications turned on YouTube. And that way you'll find out every time that I make a new video. So with all of that said, I hope that you're taking care of yourselves. I hope that you're staying safe, and I will see you again very soon here in the DroneBot workshop. Goodbye for now.